So hello, everybody. My name is Eric Novak, and I'm an AI researcher, so a researcher at the Joseph Institute at the Department for Artificial Intelligence, and I'm going to present you the fundamentals of AI. So first, a little bit of an outline. We're going to go through what AI is, where it is used. It's basically used everywhere, and how does AI development look like from the policymaker perspective, as well as from the research perspective or the development perspective. And then we're going to go for a couple of categories of AI models, deep learning, and also the problems of AI models. So yeah, let's go to the first point. So what is artificial intelligence? There are a lot of different definitions depending on what is your background and how everything, how do you perceive artificial intelligence. But basically, our wrap up is that artificial intelligence is the simulation of human intelligence with devices. So basically what we want to do is simulate what we as humans can do in our everyday lives. And computers were designed for quick calculations, which are basically just like simple operations, but they are not so tailored for the complex operations such as such as humans can process or our brains can process. Then everything was evolved through the whole evolution. So one of these processes is understanding natural language. Then another one is computer vision. This is a showcase of how, for instance, a self-driving car can see the world, and also expert systems. So depending on where you want and what kind of decisions you want to do, how an AI system can then gives you like the optimal path based on what you want to achieve. So these are just like some of the subcategories of artificial intelligence, but there are also many more. So where is AI used? It's basically used everywhere. We're just using it every day, but we're not necessarily aware about it. So one is face recognition and friend recommendations, which was first presented in Facebook. Speech recognition, such as Siri, Cortana, OK Google, and such. Search recommendations, as Google has a bias in computer, and then it gives you like some search recommendations based on previous search queries that users performed. Generating of 3D images. There we have like an image of Abraham Lincoln, and then on the right side we have the image projected on a video of how a person moves. So it is like in a way deep fake. Product recommendations, self-driving vehicles. These are like the things that we see in the media, but then in the industry, there is also helping factories and production lines. Also in the medicine domain, it allows you to help and identify different points of, for instance, of a scan and allow the doctors to identify which things the doctors need to look more at. And then also simulation of real scenarios, which is in a way described as a digital twin. So we take one system and then we want to do a computer simulation and see how different parameters affect on the whole system in real world. So this is just a short recap of everything. But how AI development looks like. So the thing is that first, we need to understand that AI is developed, or we use machine learning and artificial intelligence to help solving problems. So it's not like that we have some data and we want to apply artificial intelligence on the data, but it is more of a, we have a problem, we want to solve it, we have some data, how can we use artificial intelligence to solve this problem? And this understanding, what problems do we have in a particular system, is connected with business understanding. So here we need, as I mentioned, we need to have a strong understanding of the problems that we have. And so this includes what we want to solve, why we want to solve it, and how do we want to solve it. And this is also connected with the data understanding. So the data that is available to us to use to solve that particular problem. And then once we have this data understanding and business understanding, then from the technical point of view, it goes from data understanding to data preparation. So we need to prepare the data, and then we need to decide what kind of model, AI model, are we going to use. we train the model, we evaluate it. So what is the performance? Is it good enough to use it? Is it bad? Do we need to improve it and such? And then if we're okay with it, we deploy it so that we can use every day or every day in the system. But also, once we understand how a particular model, how do we solve a problem using a particular model based on our evaluation, we can go back to the business understanding. So we have done some experiments, we have deployed some things. So this model, we know we can now use this model and artificial intelligence in our system. And now we need to think about like, okay, so what does this affect? How can we use this do we have now a different problem? Can we improve upon the existing problem now that we have additional information based on the whole experience? And this is basically a continuous development. And we always build on top of existing solutions. So this is just like a circle, but now if we already know what kind of problem we have and the data, in a way, we understand the data. Now let's take the data understanding and the evaluation part of this circle and put it in a linear line and see how the model development looks like. So the timeline of developing the model. So first, we need to collect the data, which can be on-premise, so what we have on the machines, or we know that particular data is available on the internet. We need to look at the licensing so that we can use this data, and the data can be of different types. So it can be a text, an image, video, audio, sensor data, basically whatever we need to solve this problem. Then the next step, we need to identify or process the data so that we clean the data, add new values to it, or just remove bad data points. For instance, if we see a video that has bad quality and we need videos to build a model, we can decide that we don't use a particular video because it's too bad, for instance. We also remove duplicates if the problem requires that data fixing. So if we find that there are some typos, we can fix these typos in the text and so on. And then the next step is feature extraction. So what is a feature? Features are measurable properties or characteristics of a data point. So for instance, if we take text, this feature can be the number of characters in the text, the number of spaces, the number of words, the meaning of the words, the domain of the text, and so on. For video, it can be the length of the video, the number of pauses, the number of frames. For images can be the dimensions of the image, what are the different values, what are the different figures in the image, and so on. And this can be extracted automatically by doing statistics or using different machine learning algorithms to extract this information. So it can be like, you can layer things. So to build a model, you can already use pre-existing models to extract information that can help you then. So this is the data related steps. And usually these steps take about 80 to 90% of the whole processing or developing of the models. And then once we have the data, and also there's the feature extraction part is also connected with the models that we want to use. So a particular model can use some features, but not other features. So this is why we also need to decide at this stage, what kind of model do we want to use? And then once we have the data, we train the model, which means that we give to this algorithm, we give different examples, and we want to iterate so that the model performs better and better and try to learn something from the data that we give to the model. And then the next step is validation, which is basically just checking if the model is doing the thing that it should do. And then evaluation, which is comparing the model that we trained with other models that are already existing to see if it performs better, if it performs worse. And based on that, we can then decide which things to use in the end. And these are the model related steps. So we now have, like, in a way, a general view of how everything is produced, but what kind of models can we use? So there are different categories of AI models. One group of models fall into the supervised learning group, which is basically models that use labeled data to train algorithms to predict accurate outcomes. These are like, for example, emails. There is a model behind that says, okay, this email is a spam or it is not a spam. And here is a whole list of different problems or models that can be that we can use in supervised learning. Classification is basically the same as this spam or not spam to figure out which emails fall in which group. Regression models tell you like, okay, it's that image there. Tells you that for a given values, what is the predicted value? For instance, if you have the properties of a house on the market, you want to predict the value of that house based on existing information that you have from the market. Then you have question answering, named entity recognition, which is this middle figure where you extract, for instance, locations, percentages, organizations, dates, and so on. And then we have text summarization, text translation. We're all familiar with Google Translate and so on. So supervised learning is basically we have some data, and for that problem that we are interested in, we also have a label or some other information that we want to predict. So that can be a specific value or a class, like in classification, or in Google Translate, where we have the source text and then the predicted translation that we have. So we give the to provodi Slovenščina, for instance, as an input, and we want to the model to generate, this is a translation from Slovenian. Okay, so this is the first group. Then the second one is unsupervised learning, where we don't have labels for our data. And because of that, we then try to identify some data distribution. For instance, here would be from a group of the survey's answers based on their content. So the meaning of the answers, we want to group them together into particular like clusters. And one of the algorithms that fall into unsupervised learning is data clustering, which is presented as that image. And then you have dimensionality reduction, anomaly detection. And the anomaly detection is basically identifying when a particular thing falls out of the distribution. You have there, for instance, this line would show like the number of, I don't know, the number of downloads of a particular library. And then there is a high peak, and this is like, can be seen as an anomaly in the distribution. And then you also have meta learning and etc. So I don't want to go into detail about different algorithms, but just to have like that there are a whole catalog of algorithms that can be used for a particular problem based on the data that is available. And then a semi-supervised learning is basically somewhere in between. We have some of the labeled data, but not a lot of it. So how can we then use this to train a model? And this is the usual case where we have, like in the data set, we have some of the examples that for which we know, for instance, for emails, that they are spam or not spam, but then we have a lot of emails where we don't have this information. And from that, we then try to identify or train a model that would still solve the problem that we have. Okay. So these were some of the groups. And now we're going to go to deep learning, which is now like the basically state-of-the-art algorithms come from deep learning, from the domain of deep learning. And it's a subset of machine learning algorithms based on artificial neural networks. Basically, the model tries to simulate the brain. So how the brain is connected, which has the neurons, and then the connections between the neurons in the brain. And with deep learning, we found that it allows you to eliminate some of the data processing steps. So in that timeline that we had, some of those steps can be then eliminated because the algorithm already does the work for us. And namely, these are the data processing and feature extraction steps. And neural networks push the state of the art in AI currently, which is one of the models is ChatGPT, which we are all familiar now, I think. And for image generation is, for instance, Midjourney, which generates this kind of image where I just put in the text, like in the algorithm, I just put in the text, politicians sitting around a round table talking with each other, above the table levitating planet Earth, isometric perspective in the style of a drawn illustration. And this was generated in a couple of seconds. So you didn't need a person to illustrate, but the algorithm can then generate this kind of image. And just to understand what these artificial neural networks are, it somehow looks like this. So you have a lot of neurons and a lot of connections. Here you have the input layer, which is basically where the data comes in. And the output layer is where the information comes out. And the hidden layer is everything in between. And there is also like a complex thing that happens in between where you take all of the values, calculate something, and output a particular another value. But the idea here is just to show how these neural networks can somehow simulate the human brain. So there we have a neuron that is an illustration of a neuron in the brain. And if we overlap it across this function, it somehow simulates that it can be like a connection. And that is why neural networks somehow can be seen as like a simulation of the human brain. But because of all of these multiple connections that happen in between, and this is just a simple construction, it can be really complicated. We usually say that these neural networks or models that are built with neural networks is a black box model. And this means that we don't necessarily know what happens inside the model. And this is one of the problems with AI models. So the black box models, as I already mentioned, we generally do not know why such predictions were made, because it's just too complicated to infer something. Then AI models can make mistakes. As mentioned before, the models are trained on human data. Humans can do mistakes, and therefore also models can do mistakes either because of insufficient data, problems when training a model, and etc. And also, as mentioned before, AI models incorporate bias. Again, because of either the structure of the model or training using the provided data which were humanly generated. And both can incorporate some notion of bias. And I think that the next presentation is going to be about the bias in artificial intelligence. So thank you for your attention.